Hello guys, in this video I'm going to show you how to solve balance parenthesis problem. So for a given number n, write a function to generate all combination of n pairs of balance parentheses. So for example, with given input n is 3, then want to generate all balance parentheses, right? So for n equal to 3, it means wanna have 6 characters in total, including three opening, uh, including three opening parentheses and three closing parentheses. Okay, so there are different way to generate. As you can see, here we have three open and three close, three closing, right? Here open, open, close, open, close. But the constraint here is that we must have balanced parentheses. So all of these are balanced, right? But if we have something like, for example, uh, like first four is correct, but if the last two is like this, it's gonna be a unbalanced parenthesis, right? So in order to solve this problem, we have when we're asked to generate all the possible combinations of something, we can think of depth first search and breadth first search. A more intuitive way is to use depth first search, I think. And in this video, I wanna go with depth first search. The next video, I wanna solve in breadth first search, right? So, one observations that we can make here is that let's start from the beginning. Let's start from the beginning. Now, let's say example, wanna build up. We need to build up our balance parenthesis, right? We start with a empty string, right? So, what are the choices we have here? Can we start our parenthesis with a openings? The answer is yes, right? We can open it, right? But can we start with a closing? No, it's not going to be a balanced parenthesis, right? So it's pretty clear, right? We don't have to prove these choices, right? This is impossible for the beginning of parenthesis. Okay, so next, so right, as you can see at it at each step, we're trying to add one possible character to our string, right? The current string. So we can do something like can't start with a closing, right? So now the next step, right? Next step is to add a second character here. Can we start? Can we add a? Can we add? Can we add open? Yes, we can. Right. But can we add a close here? Yeah, we can because here is still balanced until this point. Right. For this one, uh, it can be balanced if we add, for example, like this. We have a balance, right? Or like this is still balanced. So now, next, now the third character. Uh, okay. Uh, gonna gonna look at each each string from the previous step, previous level, and we're trying to add one character to that uh, string. So for this one, can we add an opening? Yes, we can. And can we add a close? Yes, we can. As long as the newly added characters uh, doesn't break the balance of our string, it is still valid, right? So now here, okay, we're done with this one. Now move to the next one. Okay, as you can see here, can we start a open? Yes, we can. But can we add a closing one? No, it will immediately break our balance here, right? So this is not a valid one, right? So what observations that we can make here is that, as you can see here, this the number of openings and the number of closings is equal, right? And same here, the first initial state, right? Actually, the openings is zero and the closings number of closings are zero. So for those situations, we cannot add a closing, right? So can add closing if number of opening uh, can add if number of opening equal to number of closing, right? It's one observation that we can make here. Okay, next. For this one, as you can see, we're done with the openings because we've added three openings, right? The any three, so it is impossible to add one more openings, right? So the only choice here is to add a closing, right? It's obvious. Okay, we have another observations here. If number of openings equal to n, uh, can only add a closing, right? Okay, the next one. This one. Uh, Here we can. It's obvious we have two choices here, right? We have two choices here, yeah, which is, oops, which is the opening and the closing, right? So as you can see, another observation here. If number of openings is greater than number of closing, then we have two choices, right? But this one, uh, but just to make sure that our openings uh, haven't reached end yet, right? So if our opening haven't reached end yet, and the number of openings is greater than number of closing, we have two choices. Okay, let's continue here. As you can see, for this one, we also have two choices. We can open and we can close, right? The number of opening here is 2, number of closing is 1. Next, okay, again with this one, the number of openings is n now, so we only have a choice of close, right? This guys, one more close. For this one, same here, the number of opening reach n, so we only have a choice of close, right? Next one, this one. Here, it is this case, because the number of openings equal to number of closing, we can only add an opening, right? Here you can only add opening. Okay. For this one, here we have 3 openings, so the only choice here is closing. Okay. Next one. Openings equal to closing, so the only choice is opening. Okay. We have each character length is 5 now, so we have only one left character for each string, right? This one definitely a closing. Next one, closing, of course. Closing, 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 of course. Yeah. So that is when actually um, while running manually, we go level by level, but actually when the code is run, it is gonna go in depth first, right? So we're gonna use these observations to build up our code, right? So here, as you can see, we need to keep track of what the current state of string, right? So let's say the current initially is an empty string. We also need to keep track of the number of opening and the number of closing. So let's say I will call it open is 0 and close is 0. Okay. Uh, so we're gonna call this one recursively. So we need a base case here. So when do we stop our recursive call? It is when the the length of current string, uh, if the current dot length equal to all open plus close. Same here, we're going to use a size of current string equal to uh, n times 2. Okay, that's when we have a uh, complete string, right? And one piece of information that is missing here is the final result. Wanna make it a make it an array, right? Gonna add the current string to the result array, right? So at the end we have this array will store all the combination of balance parentheses. So I will add all, I will push it in current string, and I will return, right? For example, I'm here, I will return back to the previous functions that had called this one. So I will return here, right? We don't want to go in a infinite recursions, right? So now the base case is done here. Now we need to consider choices that we have here. Generally, we have two choices here, which is either add an open or add an close to our constraint, right? Generally, two choices, right? So when uh, when we are sure about adding an open, uh, I am sure about adding an open when mm, we cannot add here. So let's say add an open and 2 is add an close. When we are sure of adding an open, it is which case? So it is a number of openings. This we can only add close, right? Uh, so we think here probably if we can, how about let's try to list out all the possible cases here. Let's say this guy open equal to, that's right, case 1 open equal to close, right? If open equal to close, I can only have one choice, which is open, right? Case 2, if open greater than close, I have two choices, right? Two choices, but with the condition that the number of opens haven't reached n yet. So how I'm gonna do a check here. So case 2 would be is case 3. Uh, when close, when open is when opens equal to n, I can only go with an op and close, right? Close, right? If it's not this case, I will go with this case, open greater than, I have two choices. So when it come here, it means open is still less than n. Is there any case, other case we can have here? Okay, so let's say if open equal to close, I can else if open equal to close, if it's not the case, I will check if open equal to n. The last case is open greater than n. Okay, so if open equal to close, I can only generate parentheses and code recursively passing the n. Current will be current plus, I cannot open here, right? So it should be open. Open, the number of openings will plus one here. Close will be the same. Number of close will be the same. I will pass O as a reference, right? Okay. So if open equal to n, if it comes here, it means we can only add closing, right? You can only go with a closing here. Yeah? So open with the same, close with plus one. Or if it comes here, mm, if it comes here, I will have two choices. Uh, mm, you might think that we can improve this code a little bit, and I agree about that. But for now, just to make sure that as it will run correctly. So at the end, I will return all. So do I need to do any batch checking here? Probably no, because here I am passing a new string. I'm not modifying the current string, and we cannot modify a string in JavaScript either, because in JavaScript it is string is immutable. Okay, here I just add one to the current values and pass as a number, right? So it will not modify the open here. Okay, so I think it is fine. Let's run the test. Uh, whoops. Oh, come on. What's wrong here? Not sure. Not sure what's wrong here. Let's say this is the case. Whoops. Not sure what's going wrong here. Let's say it returning incorrect here. Our race is empty. I'm passing it correct current. Password. It will be a new string here. Open and close. Here if I open, I will add one to the open and close will same all here. It will only one of the cases. So if the number of open equal number of close, I can only add a open here. Okay. If it's not the case, I will check if the open is equal to n. If the equal open to n and outside is still less than this one, it means I can only add and close here. Open the same, close plus one, or passing as a reference. I'm not sure. Or if these are not the case, open greater than, oops, it's wrong here. Open greater than close. I have two choice. Open greater than close, and if we not one of the cases, right? Absolutely, we can. This logic can be shortened down, but I think you can do it by yourself. It's been a long video already, so maybe I will do that. I will try to shorten this logic in our breadth first search implementations, because the breadth first search approach will these logics will be very similar with this one, right? So that is it for this video, and thanks for watching. See you in the next one.